Hey guys, so yesterday we learned how to do cosine and sine in order to find angles. Today we're once again going to be using the sine and cosine ratios, but this time we're going to be finding the same side length. And once again, it's going to work the exact same way as tangent does. So this is lesson 2.5, finding side lengths with sine and cosine. Like I said, it works the exact same way as with tangent. We're just going to be using different sides. So just like with all of trigonometry, step one has to be label your sides. Then we're going to use the ratio, not its inverse, to find side length. We use the inverse of a ratio for angles, not sides. And then don't forget, when you have a fraction of like the two sides, the side on the bottom has to be the one to move, even if the x is on the bottom. So let's look through two examples here. So for the first one, I have given you your right angle triangle. So let's start by labeling our sides. So across from the right angle is our hypotenuse. Across from the side we're dealing with is our opposite. And then the other side is our adjacent. Then we are once again going to look at our SOHCAHTOA or your formula sheets. And based on the side that we have and the side that we are looking for, we're going to pick which of these ratios we need to be using. So because I have the opposite and I'm looking for the hypotenuse, I need to use the ratio that has to do with opposite and hypotenuse. So we're going to be using the sine ratio for this one. So the sine of an angle is opposite over hypotenuse. In this case, we plug in our angle, which is 42 degrees. Our opposite side is 9, and our hypotenuse is x. Of course, we need to move the x since it's on the bottom of this fraction, so I multiply by x, which cancels it out, which means I also need to multiply the other side by x. That leaves me with the sine of 42 times x equals 9. And now to get the x by itself, I need to move the sine of 42 away from it. So I will divide by the sine of 42. What I do to one side, I must also do to the other. And to figure out what x is actually going to be, I just do 9 divided by the sine of 42, like so. And I get 13.45. What were my units? Centimeters. That's my final answer. Okay, let's do one more example. This time I've given you a similar right triangle, but the angle that we were given is on a different corner than in the previous example. So once again, start by labeling my side. So across from the right angle is my hypotenuse. Across from the angle that I'm given is the opposite. And then the other side is the adjacent. And as you can see, my labeled sides are different than the previous triangle because I'm using a different angle. So this time, I have my adjacent side and I'm looking for the hypotenuse, which means I need to switch over to using cosine because the cosine of an angle is adjacent over hypotenuse. So I'll plug in my angle of 33 degrees and my adjacent side of 14. Once again, the thing I'm looking for, my x, is on the bottom of the fraction, but it doesn't matter. The bottom has to be the thing that moves, so I multiply by x on both sides. That leaves me with the cosine of 33 times x equals 14. And then in order to isolate the x, I must divide by the cosine of 33 on both sides. And so to figure out what my x is going to be, I just do 14 divided by the cosine of 33, just like that. And my final answer is 16.69 centimeters. You could round to 16.7 if you wanted. And that's it. So again, it's really just label your sides, figure out which ratio you should be using, and then plug in your terms and isolate for x. If you have any questions about this, let me know.